Differentiate f of x, which is this huge product quotient. Simplify this monstrosity by taking the natural log of both sides of this equation. By the properties of logarithms, these factors that are initially multiplied or divided together, we can turn these factors into adding and subtracting terms. Terms that are in the numerator get a plus sign, plus ln of x squared plus 1, plus ln of 7x minus 6 raised to the 5, plus ln of x minus 3. These two factors in the denominator get a minus sign in front of them, minus ln of cos x plus 2, minus ln of e to the x. Another property of logarithms, we can bring down exponents to be coefficients, such as that 5, and also the e to the x. The e to the x is like the exponent on that e, and also ln of e is, conveniently, equal to 1. We haven't done any calculus yet, we're just using the properties of logarithms to simplify this huge equation to avoid using product rules and quotient rules because it becomes really challenging to keep all those factors organized. It's much easier to differentiate things that are added or subtracted together, which is what we have now. Differentiating both sides of the equation with respect to x. The derivative of ln is 1 over something. Ln f turns into a 1 over f, and then because f is dependent on x, multiply on the factor df dx. The ln of x squared plus 1 turns into a 1 over x squared plus 1, multiply on the derivative of the inside function, 2x. The derivative of ln of 7x minus 6 becomes 1 over 7x minus 6, differentiate that polynomial inside, multiply on the 7. Ln of x minus 3 turns into a 1 over x minus 3. Just to be absolutely clear, differentiate the x minus 3, the derivative is 1. The derivative of ln cos x plus 2 becomes 1 over cos x plus 2. Then we differentiate the cosine, which becomes negative sign. And the derivative of e to the x is e to the x. We can tidy up this work. Put the 2x on top of x squared plus 1. 5 times 7 is 35. That 1 isn't necessary. These two negatives cancel to become a positive. Sine goes on top of cos x plus 2, and minus e to the x stays as is. Assignment and exam questions often want us to have a derivative that's explicit in terms of x, meaning we have to isolate df dx. We can do that by multiplying both sides of the equation by f. Notice that on the right side, we have all those terms. Those are all multiplied by f, so we have to throw in those huge parentheses around that entire side. And we have to express f in terms of x. We're told that f is equal to this huge thing, so just plonk in this big thing for f.